Hello, everyone. So let's move on to the next tutorial. Can you see my presentation?
We could, yeah, you need to go into viewing mode, that's all. There you go.
So right now you can see it.
Yeah, we can see it.
Okay, thank you so much for coming, first of all. I'm going to talk about a Python package, SBMLDiagrams, for visualizing reaction networks. It's a Python package to process and visualize SBML layout and render. So for those who are not quite familiar with SBML, so it's a standardization of machine-readable representations, systems biology markup language. So in this simple SBML file, you can see it covers the information of compartment, species, parameters, reactions, including reactants, products, and kinetic laws, and so on and so forth. So SBML layout and render is an extension of SBML level 3. So in layout, it describes the position and sizes for different graph objects, including compartments, species, and reactions. And render covers the color and shape information. So for example, the fill color for compartment, species, border color and width for compartment, species, and line color and width for reactions, and shape of nodes. So this is a simple example with reaction 2 nodes and a modifier. So SBML diagrams support PNG, JPEG, PDF via ScalePython. So you can save this image as those 3 formats. So I can share you the link. Where's the chat? So if you are interested, you can see the test suite on GitHub. There are several SBML files with the visualization by SBML diagrams. And this is another.
You're going to demo it as well later on.
Yeah, so I will show you the slides first. Okay. And then it covers several test suits from the GitHub. You can also check it later. And then I will also demo it at the end. So this is an example with orphan nodes, which means there are no reactions. So the nodes can be in different shapes, like rectangle, circle, polygon in different shapes, like lines or triangles. And the color of the node can be various, and also the border colors can be different as well. So this is another example. So this example shows that the reaction lines can be in different colors, and the text of the node can be placed outside the node, and the positions can be designed as you want. And it also covers alias nodes. Alias node is the common node or between or among different reactions. For example, X1 is the common node of these 2 reactions. So this is quite useful for large-scale reaction networks. It can help with the visualization of the complicated reaction networks. by avoiding the directions cross with each other. I'll show you more examples later. So this is another example. It shows the compartments can be in different colors, and also border nodes can be different, aliens node in different shapes, reaction lines in different color. This is another example. It shows a real example from Glyco's model published in 2001. So as you can see, there are boundary nodes with thicker boundary lines, and also aliens node in dashed borders, and also Bezier curves, and long text will be automatically fit with adjusting the font size of the text. So sometimes the SBML files has directions with centroid in a shape. So this is an example with the reaction centroid as a circle marked as here. As you can also see, the lining of the arrow of direction can be in different field color. So this is another real example from the minimal model of metabolic oscillations published in 2020. So in this reaction, it also shows the centroid, the circle. You can also add text inside. And this reaction is also kind of special because some of them do not have reactants or products. So for example, in this reaction, there's only reactant, centroid, but no products. And in this reaction, centroid and product, but there's no reactant. So SBML file also support this kind of reactions. This is another real example, an SBML file of the deterministic SEIR simulation of a COVID outbreak published in 2020. So as you can see with the layout render, it can support different font color as the text of the node, and so on and so forth. So this is another complex example generated by Minerva, published in 2016. So as you can see, the nodes can be quite complex with several subnodes inside, and text can be placed at the bottom of the node. And also directions can be in dashed lines, and lining of the arrows can be solid arrows, or this just simple arrow, or complex shape of polygon. And also the modifiers can be in different shapes like circles and polygons and so on and so forth. And the nodes can be in different shapes. So it also, so the render and layout can support those different shapes and colors of nodes and directions. Okay, so after seeing some visualization examples of SBML files, now I'm going to show you how we could process SBML diagrams, this package that process the SBML file to add or edit layout render. So I'm gonna share some links to you. So the first link is in the documentation with the section of tutorials, some examples of visualization and how you can use the code. And next one is on GitHub, that with some code examples that I'm also gonna share with you here first. So this is simple example is that you can first import SBML diagrams, Python package, and then you can cooperate with a Telegram, which support antimony like this, and also in Python language. So if you use the antimony to generate a model, and then you can get the SBML file, and then load it to SBML diagrams, and then you can visualize it by just a draw function. And in between, if there's, because there's no layout or render information, then you can use auto layout. It will give you a default render and also auto layout of this model. I'm gonna show you some examples later for the auto layout. So for SBML diagrams, it does not only support the visualization, but it can also set the render and layout of the SBML file if there's not, or you can also edit it by SBML diagrams. For example, after you load the SBML file, then you can set the direction line thickness by let it know the direction ID and the line thickness by a float number. And you can get the SBML updated file with this render information by a export function. And then you can write this SBML file updated to a new SBML file saved. So what else can it do? So basically, in general, we can say it can load, read, edit, and export to an SBML file. So for example, so you load an SBML file first, and then if there's information about layout and render, you can get the layout and render information by SBML diagrams. For example, you can get the compartment position by giving its compartment ID, and get the node size by giving its node ID, and get reaction center position by giving reaction ID. You can also get render information like the compartment field color, get node shape and reaction field color. You can also set layout render to change the existed SBML layout render information in the SBML file, or you can add if there's not. So for example, you can set compartment size by giving the compartment ID and the size. And then you can set node text position by giving the node ID and the size of the text. And you can also set the render information. So render covers the shape and color information. And for example, the color, we support 3 formats. The first one is decimal RGB, which is 1x3 matrix like this, and also support HTML name like white, red, so on and so forth, and hex string, 6 digits like this. So for example, you can set compartment border color by giving the compartment ID and this RGB matrix, or set node field color by this red and opacity, and node text font color by giving this hex string and opacity, and set reaction line thickness as I have shown the example in the last slide. And then once you export this updated SBML file, you can save all the render and layout information in one SBML file. Okay, so let's see some simple example. If you use Telegram and import an antimony model, you get the SBML file loaded to SBML diagrams. Then you can arrange this network a little bit by set the node and text position to arrange the node positions of these nodes, and then move the node text as you like. For example, this one, I'll set the node shape. For example, the default is rectangle, but you can set it to ellipse like this, and set the nodes, node shape, node size, border width, border color, and you can also set the text only shape here and enlarge the text font to 20. And for the reactions, you can set default center and handle positions, which means it's like a straight line here. And then you can set this reaction as dashed style as you like. you can also set the center and handle positions to change it to a Bezier curve as you want. And then finally, set the image you want to export, the size of the image like this. Then let's highlight something more. So as you can see, SBMLDiagrams is kind of tedious. So once you want to assign anything, you need to do it one by one and tell the exact position. But sometimes it's quite helpful if you do similar things for each node. So for example, this is the original file, and then you want to set all the nodes to circles, so you just use one function. So if it's aliens node, or if it's not aliens node, then you can set the node size to a smaller one, and you can set the node position, and you can set the text relative position and node shape, node border width. And as all those nodes will be set similarly, so you can use only one function to complete this process. Okay, so so I have already finished the basic functions of SBMLDiagram. So let's see if it has some interface to other things like other communities and anything more interesting. So first of all, it can have an interface to SVGN. So in this example, as you can see, this is a complex node. And first of all, you can set the node and text position as you want. And then you can set the arbitrary polygon shape like this by giving the vertex nodes, vertex points. And then you can add rectangle and circle and text as you like. And then you set the default direction positions of centroid and handles like a straight line. And you can also add ellipse, those are for SVGN as you like, those arbitrary shapes, and then you can export this figure. This is an example to SVGN2. So once you load the model, there's no layout render, then you can set the node and text position, and then change those to ellipse for circles, and then default centroid and handle position like straight lines. And you can also set the add a rectangle here for SVGN shape. And you can also set the gradient node from white to silver here, and set the node border color to black. As I have mentioned at the beginning, the simple example, once you load an antimony, there's no SBML layout and render information, then you can use auto layout to give you some default or primary positions of a network. So we have this kind of auto layout options for you. I'll share this link too, so you can see more information in the documentation. So for example, I have 4 examples here. So spectral and spring, you can adjust the scale of it, which means the total size of the network or the node, the distance between nodes by adjusting those 2 parameters. You can also choose auto layout as graphics, dot, or neutral or other graphics program. We have some options. And for example, you can see this primary auto layout so far is that this is spectral, this is spring, This is graphics dot and graphics neutral. So you can adjust the those primary auto layout if there's no layout information in your SBML file. We also have interface to color style from SBMLDiagrams. So the color styles can be written in JSON files. So for example, in this default color style, there are compartment field color information, border color, field color of species, border color of species, direction line color, landing of directions, and landing border color of the direction line, and also font color of the text. And also for animations, I'm gonna show you later for program bar field color and so on and so forth. So once you have this JSON file, you can load this color style to SBMLDiagrams, and you can load an SBML file without the render information. And then you can just set the color style with the name here, like default, and then set the color style of red, ombre, and so on and so forth, different color styles. Then for one SBML file, you can have this kind of color style gallery with the stored color style JSON file. And you can also reuse those JSON files for different SBML files for later use. So you can reuse this color style if you like it for further use later. So we also have the interface to animation. So if you import SBMLDiagrams and Telegram, you can load the model and load the SBML file, and then you can do this animation function. I'm gonna share you a link with the animation. So I can also show you here. So as you can see, there's oscillations in this SBML file. Then with this animation, you can see it clearly how the concentration changes with the progress bars. Okay, so this SBMLDiagrams is available on pip PyPI, so you can pip install it if you're interested in using it for visualization of reaction networks. And we have documentation covers the introduction of some visualization examples and also tutorial of the codes. And we also have test suite in GitHub and also examples in GitHub, which I have shared the link with you. And also the article is published online. So if you're interested in how to use it and what kind of thing this package can be used, you can also refer to the article. We have a supplementary, so you can see more examples and details about this. So now I'm gonna share you the PyPI to you, and also the article to you. Before I do some more tutorials, do you have any questions regarding the slides?
One question is, are there any other applications that can read these SBML files and show the network?
So like the Copazi and one work we are doing Coyote and also Manava, the file I have shown you with complex node in this slide. Those three are the only three so far support SBML layout and render level 3.
Okay.
So the Coyote we have not published. Only Copazi and Manava support SBML level 3 so far, but they are based on GUI. So for example, like if we have some tedious, we change the similar nodes. So far, they have to change it one by one like that.
Mhm.
Yeah. So so far, our work is.
Is it possible to give a live demo where you create a model and then load it into then show the picture and then load it into Copazi to show that it works?
Sure.
I think that might be just a simple model, you know,
Okay.
or even the glycolysis model, I guess, would work.
Does Cell Designer have a similar function?
So Cell Designer does not support level 3. It has its own system of layout, but it's outside SBML extension of layout and render. So the answer is they have
the answer is
similar
no.
function, but it's a kind of different.
It's unfortunate that is actually, that they're not following the standard. So, but this is the one that's going to be used by most other tools in the future. So
Would you mind, I'm probably just a little ignorant there, would you mind just explaining a little bit further the difference that you see between what Cell Designer does versus?
Oh yeah, okay. So all this information is stored in the SBML file. Okay, the colors and so on, they're all stored in the SBML file, and they're stored in a certain way that was agreed by the community. Unfortunately, Cell Designer, they have their own way of storing the colors and shapes and so on, which is not compatible. So Cell Designer will not understand the official standard for representing colors and shapes and things and coordinates. That's the problem. So if you create a model with Cell Designer with all your nice layouts and so on, you can only use that in Cell Designer. You can't use it in any other tool. Does that answer your question? I think maybe.
Yeah, that's perfect. Thank you.
Yeah, we're hoping, you know, we can persuade them to switch over. That'd be really nice then.
So I can.
Will these slides be available?
My slide.
Yeah, that'd be nice.
Okay. Actually, the video will be online later.
You could put the slides on GitHub, maybe.
GitHub.
Yeah, no, GitHub.
Or if you had a notebook or something, it looked like you did it in a notebook would be quite helpful.
Oh yeah.
This is actually very relevant to some work we're doing, and we may use this tool. So
yeah, sure. Yeah, we can get you the notebook. It's what is it? Is it a Google Slides? Is it, Jen?
I can share it later. It's not in Google Slide. I can share later, probably.
Okay.
Page share might be another place if you wanted to put there.
It's not currently on Google Slide yet, so I can share later.
Yeah, put it up on there, and then so Will, you may want to send us your email address or something.
I can share my
your email address. Yeah, that'll work. Yeah.
Will, would you mind to remember this email, and then I can share my slide to you later?
Will, have you got that email address?
Yeah, got it. Thanks.
Perfect.
Perfect.
Great. Yeah, just send an email to Jen and then she'll send back the slides. So you want to show us a
Okay,
quick
so
demo?
now,
Show
yeah,
us a quick demo.
yeah. So I'm gonna show you a demo. So
Now I should add the SBML files that are generated this way. I mean, Cell Designer will still read them. It just won't know what to do with the layouts, and so it'll just produce a random network, I think.
yeah, Cell Designer has its own system of layout. So if you load the XML file with the layout and render information as an extension, then they won't recognize it, but will randomly position those nodes
Yeah,
as the Cell Designer system.
yeah.
So this so I use the Windows spider of Telegram here, and then I can show you the examples again here.
Now just show us the glycolysis one. That'll do. Jana Wolf. Just do the Jana Wolf because the others aren't that interesting.
Animals
Yeah.
like this.
Okay. So that's how it renders here. So now if you go to Copasi and load the same model into Copasi, show us what you get.
Let me find the file first.
Okay. And there it is. Almost the same. Why are they putting arrows in the middle, I wonder?
This one I'm not sure, but I can fix this.
Yeah, but is it a Copasi problem or our problem?
Actually, Copasi only recognize species reference. It cannot recognize the direction graph itself. But I can fix this by changing the export. I have already fixed this in Coyote already, so I found this point. So I think I can fix it. Yeah.
But this is a Copasi. This is a Copasi issue, which we can sort of fix at our end for them.
Yeah, so I can fix from the exported SBML file from my set, to compile. For example, in the Copasi, in the Coyote, I have shown you that the Coyote has fixed this problem.
Oh yeah, right.
So the Coyote has fixed this problem. There's nothing here because Copasi, they won't support direction graph if there's no information of the species reference graph in directions. So I need to fix this a little bit more.
All right, thanks for the demo.
Okay,
so we're currently also building a Visual Studio Code platform that will be using SBMLDiagrams. The idea being that when you run a simulation, the results can be layered onto the diagram. So that might be interesting to look at some point. Okay.
Okay, so do you have other questions? So If not, we can close this session. And then if you have other questions, you can either refer to the documentation I sent to you, or you can email me for further applications or questions or comments to improve this. Also, if you are interested to give us comments for improving the tutorials, please also let me know.